If you haven't yet watched the video on exercises 1324 and 1325, I recommend that you go back and look at those first, as well as if you haven't looked at the overview of these strategies or the questions that are asked in order to sort of guide our proof construction. I also recommend that you go back and look at that first, as well as have the guide beside you. Okay, so one of the first things that we're supposed to do when we look at the strategies for doing proofs is to first understand what the various sentences mean. So we have as our goal the claim that there exists something that is a slithy. And we're asked if that follows from the premises. So here in this third sentence, this third premise, we have not an existentially quantified sentence, but rather a conjunction. Now that conjunction consists of two existentially quantified sentences, but the important part is the thing that is a tov need not be the thing that is brillig, because this X here is being bound by that existential quantifier, not the quantifier out front. So that's really important, right? It's true that if there's something that is both brillig and tov, then sentence 3 would be true. But it's not the case that all the ways to make sentence 3 true means that there has to be an object that is both brillig and tov. You can have two different objects, one that is brillig and one that is tov, and 3 is still true. That's important here. Okay, so sentence 2 says that anything that satisfies either condition of being tov or mimsy is then slithy. So sentence 2 is a universally quantified sentence. That is a rule that says anything that satisfies either of these conditions is then going to be slithy. Now the very first premise is also a universally quantified sentence, but it says, okay, anything that satisfies both conditions, so notice that we've got the conjunction, anything that satisfies both being a brillig and being tov will then satisfy the claim that's being a mimsy. Now, if we look at the combination of these premises, right, and if you mistakenly read 3 as being there exists at least one object that satisfies being both brillig and tov, then your reasoning might mistakenly look like the following. Well, I've got an object that's both a brillig and tov. Premise 1 says that anything that is both a brillig and tov is mimsy. Premise 2 says that anything that is either tov or mimsy is going to be slithy. Therefore, I have something that is slithy. The mistake in this, that type of proof, is the thinking that there is an object that satisfies both being brillig and being tov. So if you did a proof that followed that strategy, you actually won't be able to satisfy it. You're going to make a mistake. And the main mistake is going to be related to the restrictions for the rules of inference, right? Because 3 is a conjunction and not an existential claim, right? You're going to be forced to have two objects that have different names. And because they have different names, you're not going to be able to satisfy this first condition, because this is saying that there is an object or any object that satisfies both of these conditions is going to be mimsy. So a proof that follows that sort of a formal proof that follows this sort of informal strategy that starts with the mistake that we just made, right, which is thinking that there's a single object that is both brillig and tov, is in fact not going to be a legitimate proof, and it won't work at all when we try to formalize it. That doesn't automatically mean that this argument is not valid. In fact, if we go back and we think about this second conjunct, right, that there exists something that's a tov, we'll notice that that actually satisfies this first condition in the second premise. So we have an object that is tov, and 2 says, hey, anything that satisfies either the condition of being a tov or being mimsy, anything that satisfies one of those two conditions is slithy. And that is actually what our goal is, right? So in fact, there's a whole proof that we can do that doesn't even need to make use of 1 at all, and in fact doesn't need to make use of the first conjunct here, that there exists something that's Brillig. Now, the reason, again, why we ask you to understand what the sentences mean and come up with an informal proof first is because if you skip that step and you just start blindly following through the strategies, you're going to be misled about how to do the proof, and it won't work out, and it'll be really frustrating. So as we first come to recognize what the sentences mean, and when we have that correct interpretation, then think about our informal proof, then we start realizing how to actually do the formal proof, right? And recognizing which pieces of information are going to be relevant to that. So knowing then that I'm not going to need one, and knowing that I'm not going to need the first part of the conjunction, I'm going to start doing a proof strategy where I start walking through the questions. And one of the questions was, is one of the premises a conjunction? And the answer is yes, so I should do conjunction elimination. And the thing that I want to have in particular is the conjunct that is going to be relevant to the informal proof that I was doing. So I said I don't need the claim that X is Brillig, but I do need the claim that X is Tove. So I'm going to do conjunction elimination, doing there exists an object that is Tove, and that's going to be conjunction elimination, citing line 3. Now I walk through the questions again in the proof strategy, starting from the top. And if you start from the top, you'll notice that one of the first questions that you're going to get to related to quantifiers is one of the premises, or here, right, a step that we've gotten from the premises, an existentially quantified sentence? And if the answer is yes, we need to do existential elimination. Existential elimination requires a subproof where we assign a name, a temporary name, to the thing that is a Tove. So A here has not been used anywhere above, so I can use that here. And I'm going to say that A has the feature of being a Tove. My goal is to get to the claim that there exists an object Z that is slithy. And if I can get to that conclusion, then I can get rid of the initial assumption that I made, which is that A is the thing that is a Tove. So I will use number 4 to say, let me give a temporary name to the thing that is a Tove. I called that A. Under that assumption, I was able to get to the claim that there exists something that is slithy. And so now when I get back out to line 8, I'm saying, okay, let's just get rid of the assumption that A is a thing that had the feature of being Tove, because we didn't need that in the conclusion. So when I check that step, that in fact works out. Step 8 works like that. So now I can focus on what's going on inside this subproof. And I walk through the questions again, right? Starting again all the way at the top, right? Is there a conjunction? Is there a disjunction? Are there conditionals, right? All of those questions that I'm asking are not going to be satisfied. And I'm also going to get a place where I have a step that is an existential quantifier, but I've already made use of that to do existential elimination. So now there are no further guesses to those questions, and I get to the one that asks, is the conclusion or subgoal a existentially quantified sentence? So number 7 satisfies that question, right? I do have a goal that that is an existentially quantified sentence. So what I want to do beforehand is get to the claim that say A is slithy. If I can get the claim that A is slithy, then I can do the, from 8, right, existential introduction. So here I'm working backwards. I'm saying, look, if I can get the claim that A is slithy, then I can say there exists an object that is slithy. And I need to cite number 7, and that step will now check out. Okay, so now I run through all the questions again, and I've sort of satisfied the questions related to the existential quantifiers, but there's also questions about the universal quantifiers. I don't have a goal that is a universally quantified sentence, but I do have one of the premises that is a universally quantified sentence. And I can make use of those, right? So I can, for example, note for number 2, right? That's a universal quantified sentence. I can do universal elimination on that. And when I do that, I don't have to worry about names that I've used beforehand. I get to input whatever name I like, right? Since everything is going to match or hold to that rule, if it does at all, I can say that of any object. So I can take 2 and write down if A is a tov, or if A is mimsy, then A is slithy. So that is universal elimination. So now I run through my questions again. I know this might sort of feel pedantic, but honestly, the order of these questions can be really, really helpful for you. So I'll get to the question where one of my premises or one of the steps that I've gotten from the premises ends up being a conditional. With a conditional, I can try to do conditional elimination. So if I can get conditional elimination, I could get step 8, right? Because the consequent of the conditional matches what I actually want. But if you try to check the step, you'll notice that it won't work, right? And the reason why it won't work is because I also need to have the antecedent. I also need to have the first part of that conditional. So I need to build that somehow. If I could have that, if I could have tov A or mimsy A, right? If I can have the antecedent and the conditional, now I could write down slithy A. So that's the conditional elimination. So what I'm left with is this one step, which is a disjunction. Now, one of the things that I had pointed out in the list of the strategies is sometimes you need to sort of deconstruct sentences to get to something that you want. And other times you have to build them up through the various introduction rules. Those introduction rules are conjunction introduction, disjunction introduction, and the conditional introduction. Here for 7, we'll notice that, okay, we've got a component of 7, but we don't yet have the entirety, right? We don't have the disjunction. That's to say, I've got in line 5 the claim that A is a tov, but I don't yet have the claim tov A or mimsy A. But I can build that and use a rule of inference, which is disjunction introduction. If I've got the claim that A is a tov, well then anything that I disjoin with that is also going to be true. Any disjunction that includes A as a tov is also going to be true. So when I check that step, that works out. And now I've got a justification for each of the steps that I've needed, and you'll see that the whole proof now actually works out.